Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on machine learning algorithms. Under this supervised learning, we have covered two videos where we have gone for the regression as well as the classification. In the regression series, first we have gone for the simple linear regression. Today we will go for the implementation of these simple linear regressions. So for that what you need? You need Python with that Anaconda flavor to be installed, and by the default Jupyter also will be there. So I am typing here Jupyter. So you can see, it does not come here. I typed the wrong thing. So Jupyter, when you see the Jupyter notebook appears Anaconda 3, you can see it here. Then just simply run as administrator, select yes, it is there. Now you can clearly see whatever the files I have executed, it is in front of you. Just now I did it, I think it is 5 minutes ago. That is the linear regression that I am going to explain you now. First of all, as I told you that we need to go for importing some packages or some library functions. First of all, we have to install, then we have to import. The very first Python library we need, that is NumPy. So this NumPy, it stands to the numerical Python, and it is a package used for scientific computing with Python, that you can clearly understand. So just I already installed that, so I am using hash. So pip install NumPy, then import NumPy as np. So it is already installed, that's why I am putting the hash signs. It means it is the comment. So once you remove the comment sign, so it will install first time also, there is nothing, no problem. Similarly, we need some other library files like pandas, and this pandas is a Python library that is used for working with the data sets. It has a function for analyzing, cleaning, exploring and manipulation of the data or manipulating the data. So how do you get that one? Pip install pandas and import pandas as pd. So this is over. Then immediately we should have the data set with us. Suppose you are working on the tvmarketing.csv. So this I have taken, downloaded from kaggle.com. I put it a folder, that is machine learning tutorials, here on the desktop. So I have created, and I have to read this data, that is pd. What is that pd? Pd is for using for this pandas. So I am using a method read_csv, pd.read_csv. Then where is your data set is there, you give the path there, and that you save it under this advertising. Okay, so whatever the data you loaded and the data you read it there, that is stored in the advertising. Now I got it now. So this is again I am putting the same thing here, how to read the data. So 3 and 4 are repeated, nothing to worry. So now I want to, so how to run all the things, just you click it here, you see initially green and then blue there, shift enter, just press shift and enter, it will run and automatically it will install. Okay, similarly here also the same thing, shift and enter here too. Here also when I am reading this data, the data set, also you see by default it is coming green, then I am clicking it here, it is coming these things like this, it is coming. Okay, then what you have done, then how to know what is the shape. So there are 200 number of rows and 2 number of columns. So how to get it? Using the dot shape command. So advertising dot shape, what is that advertising? Advertising is the variable where I put the data set after loading and reading. Clear? Then suppose I want to know information about this advertising, then I can use the method advertising.info here. Here you can see, you see by default that green color is appearing. Just you click it here once, again the color is turning into blue color. Then you can go for the person. Suppose you want to create a line below this, press B, above this press A, everything you can do, right? Now when I want to know the information about this advertising, then I write advertising.info and shift enter. Then it says we are having two things. One is the TV column, first column is TV, second column is the sales. It's clear. And we are having 200 number of data, that means 200 number of rows and 2 number of columns. It's clear. Then if I want to describe what about this, what is the advertising, then you can say there are 200 number of count and all the data in TV head it is there, and also sales head of 200 data is there. What is the mean data it is there, what is the mean, and mean also here, how many TV advertisement is given and how many sales are there, what is the standard, what is the minimum, what is the maximum, and all this data, all the details it is given there in the advertising.describe method. Then suppose I want to find the first 5 lines of data, then you can write this command advertising.head method, it gives the first 5 lines. Similarly advertising.tail, so what you do, just do it here and shift enter, so this data it is coming. Similarly advertising.tail, the bottom, the last 5 data also it come, because our is the 200, the last data we don't want because some other data is there. So last 5 data 195 to 199, this data I have given. It's clear. Anyway, the first data, because it is starting from 0, so 0 to 199 it is 200 lines of rows, right, or rows. Then suppose I want to take some sample, randomly I took it, say random, so advertising.sample2, only 2 number of sample I want to take it here. So then one sample that is serial number 72 and 117 randomly has taken. So when the TV advertisement is this one, then sales is this one, like that I have given it there. Then we will be using the C burn. So this C burn we will be using for plotting the scattering plot TV versus the sales. What is the TV advertisement is giving and what is the sales? Okay. For that, what is the library functions we will be using? That is the C burn. So import C burn as SNS. Then SNS, that is the C burn. Okay. SNS dot pair plot, that is the data is advertising. The X variable is TV and Y variable is sales. Size is 7 and aspect is 0.7 and kind is scatter. Now what I have done, so this is the scattering plot, just it is scattered here, you can see it here. If you observe this data, the visualization, so it is there, it is the increasing order and it can be mapped to a linear graph or the line, so which we call it the linear regression, that we will see. Then what is the data? In the x axis it will be representing advertising of TV, then y axis advertising the sales. Okay, from this advertising TV is represented in number of TV advertisement it is here, and the number of sales it is coming the y axis. Okay, so x is represented like this and y is represented like this. Is clear? Then we need to split the data into training, testing, and of course validation is there, that we are not bothered about at this moment. So we are only going for the training and testing of the data sets. So we can make it 50-50, you can make it 70-30, you can make it 80-20. Here we tried 70 and 30. That means training size will be 70%, that is 0.7, and the test data it will be 30% or 0.3. There is no need to mention that one, only one is enough. Train size you give it, automatically test size it will take. So for this again you have to use this sklearn. So from sklearn, so this is already it is there, already the library package. From sklearn dot model selection, import train underscore test split, train underscore test underscore split. What are the things? One is the x train, x test, y train, y test, which is equal to train test split of x y train, size is equal to 0.7, and the random state it is used for the random number generator. So that's why I am putting random state which is equal to 100. Now train test split. So these are the things it will be there. So when I run this one, it is showing this function etc. is already there. It is there. Then I am going for this x train is equal to this one and x test is this one. Then I run this one also, it is coming. Then what I do? Then I have to import the linear regression, because till now only I am pre-processing of the data and just I am doing it here. Where you get this linear regression or this type of regression? So we will get it from this sklearn or sklearn. Okay. So import linear regression from sklearn, that is the line number 18, you can see it here, and from sklearn dot linear underscore model import linear regression. Okay. Then this linear regression method I put it as a variable LR, representing the linear regressions, creating a linear regressions. It is the object is created LR. Okay. Now LR dot fit x train and y train. What is the data? I am providing 70% of the data as x and it is mapping to y, this x train and y train. So this I want to fit it into a line. Got it? How to do it that one? LR dot fit x train comma y train. Then when you run this thing, it is coming linear regression method is successful. It's clear. Now suppose I want to find what is the LR intercept and what is the LR coefficients. What is the coefficient intercept? So if you see this equation, B0 is the intercept and B1 is the coefficient. It's clear. So for this I have to calculate, it calculated intercept. What is intercept? Intercept is the B0, that is 6.98 something, that it is appearing here. So similarly the coefficient it is calculated, it is there coming. That means it is represented in the form of y is equal to B0 plus B1x. That means a linear regression, so we set it. And then what is the x underscore test? So we have 30% of that means out of 200, 30 number of rows data is there. Similarly y prediction also it will be for the corresponding, that this will be there. Now we have calculated the x test, then the corresponding y prediction also value also we have conducted. Now we go for the performance checking of this model. For that what you need to do? You go for the computing the root mean square error and R square value. How you calculate? So here we can go for a package matplotlib. So import, that means actual versus the predicted. We want to plot it. What is the difference? That is the error. So import matplotlib.pyplot as plt. C is equal to these things and figure plt.figure, which is showing it here. Then in the plt.plot C y test, that color is equal to blue. C, that means the test data and predicted data. Test data is represented in the blue color and the predicted data is represented in the red color. What is the difference? That is the error. Okay. Then we put the plt x label as index and y label as cells. Okay, here I am writing index and here I am writing cells. Written. Then what I do? I have to calculate the error. How do you calculate the error? So error is equal to y test minus y prediction. Why? Because y test, so one is the red color, one is the blue color, the difference is the error. Okay. So that is there. Then I want to plot it. Okay. Figure plot. Then y minus this, that is the error. The color is blue and all the things it is given it there. Then I go for this plot heading, x label and y label, all the things I put it there. Then what I do? Then it is calculated like this and you get the plotting it here. Man, what is the difference error between the actual and the predicted, that you get it here. Then I have to calculate the mean square error. This mean square error calculation also you can do it from this sklearn. So from sklearn dot matrix import mean squared error and also R square score mean absolute error. So this MSE is calculated like the mean underscore square error. How? Now out of this y test and y predicted. So out of this the difference is there. So you have to take, that is the error, and you take the square of that one, then average and square root of that one, that is the mean square error. So the mean square error we got it, our RMS we are not going. So mean square error we got it there. So that is stored with the object MSE. Then if you type MSE around this MSE, the MSE value is this one. Okay, that is the mean square error is this one. Then what I do? The R squared value also I want to find, because as you know these are all used for this the accuracy and all things, right? Then the mean square error put it as MSE and R square error put as R squared. Then the value it is coming, mean square error it is coming this one and R square value it is coming this one. Okay. Then if I go for a plotting of all the things, y test is this one and predictor is this one. Now that means I provide some test data there now, and the actual the predictor it will be predicted. It's clear. Now putting all the things, you got it there. Now you can clearly see the entire process what I explained you, that is related to the linear regression. So okay, and this is the simple linear regression. So starting from what are the library functions or the packages we will be using, and where is the data, how to load the data, and how to make the pre-processing of the data, then what are the other packages you are using, Skylearn or Matplotlib, all things we did it there. I hope it makes some meaning to you and makes some sense to you. So if you like this video, please do share with your friends, and also don't forget to subscribe. And this something also you want to get the new videos without any hindrance, so please do subscribe and share with your friends also, so that all the new videos will reach to you without any delay. Thank you for watching this video once again, and please take care of your health. Have a good day. Good night.